Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on August 7th, 2025, so just yesterday. This paper introduces a new platform where the action model, GE ACT, can make a sandwich with a 75% success rate, while previous top models scored 0. The paper is titled Genie Envisioner, a unified world foundation platform for robotic manipulation. And as we'll see, its ability to generalize to completely new robots is really impressive. The authors achieve this by integrating policy learning, evaluation, and simulation into a single, cohesive video-generative framework. Also, the authors shared their official GitHub repository for this project. The full implementation isn't quite there yet, but it's the official home for the work, and they have a to-do list noting that the code and model weights are coming soon. Alright, so this diagram gives us a great overview of the whole platform. At the very center, you have GE Base, the World Foundation model, which is trained on over 1 million real-world robotic tasks. It takes in what the robot sees and a language instruction to create latent features, which are essentially a compressed understanding of the task. This understanding then feeds into two key modules, GE ACT, which generates the action policy for the robot, and GE Sim, which acts as a world simulator for testing. And here we see GE ACT put to a really impressive test. This top series of images shows the system working on a completely new robot, the Agilex Cobot Magic, which it never saw during its main training. It learned this complex task with only 1 hour of teleoperation data, which is when a human remotely guides the robot to perform the actions. The bottom row highlights the key steps. The robot assembles a box, places candy inside, closes it, and then has to remember which stamp to use, which is now hidden. Building on that, this diagram shows us the architecture of GE ACT itself. On the left, it takes in video and text, which flow into the main GE base model to create a deep visual understanding. But the key innovation is the parallel action model shown here. It uses a mechanism called cross-attention to connect that visual understanding directly to a concrete action plan. This lets the system generate a final manipulation trajectory for different robots without needing to render a video, which is much more efficient for real-time control. And these charts show us just how well that GE ACT architecture performs in the real world. The researchers benchmarked it against two other leading models, UniVLA and GROOTN1, on 5 different tasks. They measured success in 2 ways, a stepwise success rate, which checks each part of the task, and an end-to-end success rate, which only cares about the final outcome. Across the board, GE ACT, in both its slow and fast versions, comes out on top, often by a huge margin. So, we've seen how GE ACT performs, but how good is the underlying world model, GE Base, that powers it? Well, this figure compares it against other major video models, like OpenSora and Kling. The radar chart on the left breaks down performance on key robotics metrics like temporal alignment and dynamic consistency. And the table on the right shows the final aggregated scores, where GE Base has a significant lead. This specialized training on robotics data is what really sets it apart from more general video models. This table then shifts focus to GE Sim, the platform's built-in world simulator. Here the researchers test its ability to generate a realistic video based solely on a sequence of robot actions, a process they call action condition simulation. Using their EWM bench, which is a benchmark tailored for these robotic world models, the results are very impressive. The scores for spatial alignment, temporal alignment, and logic are all extremely high, confirming the simulator is a reliable and consistent tool for developing new robot behaviors. So putting it all together, the Genie Envisioner platform really stands out by unifying policy learning, simulation, and evaluation into one powerful framework. This integrated approach allows it to achieve impressive real-world performance and generalize to new robots with very little extra data. That's it for this episode